So hello guys, I'm Dhananjay Mishra. I hope my voice is audible to you clearly and perfectly, crystal clear. And I hope that my screen is also visible to you perfectly. Just let me know if there is any issue regarding the voice or the screen sharing. Hello guys, can you just please let me know whether my voice is breaking or anything issues regarding the voice and or screen sharing? Okay, so let us start. So today we'll be discussing a DSA problem which was recently asked in PayPal interview. So the problem statement reads that we have to count pairs in array whose sum is divisible by k, right? So let us first of all read the complete problem statement. So we are given an array, and the array consists of positive integers, and we are also given a positive integer k, right? So our task is to count total number of pairs in the array whose sum is divisible by k. So the question means that we are given an array of integers and we are given an additional positive integer k. So what we have to do is that we have to count the total number of pairs. Pairs means like a pair of two elements. We have to determine all the the count of all the pairs such that if we sum the two elements of each pair, then their sum will be divisible by k. Divisible by k means that they will be perfectly divisible, right? The sum of the elements of the pair will be perfectly divisible by k. That means remainder will be 0, right? So let us first of all look at the first sample test case. So in the first sample test case, we are given an array, right, of size 6, and the array element reads as 2 comma 2 comma 1 7 5 and 3, and we are given an additional k positive integers with whose value is 4. So now we have to determine the total count of pairs such that sum of the elements of each pair, that is sum of the two elements in each pair, is perfectly divisible by value 4. In this case, k is equal to 4, right? So let us now understand the output and why it is coming 5, right? So the output is 5. That means we have total number of 5 pairs. So the explanation is that the 5 pairs which are possible in this sample test case are like 2 comma 2, right? So let us understand how these pairs are coming in this answer, right? So 2 comma 2, if we take the pair 2 comma 2, then the sum of this pair becomes equal 4, and it is perfectly divisible by k, that is 4, right? So the remainder is here 0. Similarly, 1 comma 7, the sum of the elements in this pair is 8, and it is also perfectly divisible by 4, right? So the remainder is 0. Similarly, for all the pairs, 7 plus 5 gives us 12, which is perfectly divisible by 4. Similarly, for 1 and 3, the sum is 1 plus 3 is equal to 4. And similarly, for 5 comma 3, the sum is 8, and it is also perfectly divisible by 4, right? So the count of pairs is 1, 2, 3, 4 and 5. Cool. So it is our first pair, second pair, third pair, fourth pair and fifth pair. So the answer is 5. I hope you understood why and how is the output 5 coming. Right. So let us look another sample test case. So here we can see, so it is the basically GFG portal, and the problem link I'll be sharing you with in the description below, so you can go there and submit the problem statement, right? So let us discuss about the second sample test case. In this, we are given another array of positive integers and a value k equal to 3, right? So the total number of pairs possible such that sum of each pair is perfectly divisible by value 3, right? So there are 7 pairs, namely these, right? So let us now look about the constraints. So the expected time complexity to us is big O of n, and we can use space as much big as big O of k, right? So the total number of elements, the max limit of the elements can be 10 raised to the power 6, and the minimum value and the minimum number of elements in an array we can have is 1. The value of each element of this array lies in the range 1 to 10 raised to the power 6. Similarly, the last constraint is that the positive integer k will lie in the range 1 to 100, right? So let us now discuss how we'll solve this problem. So after getting understood the output and its explanation, the first thing which comes in our mind is that what we can do is that we can pick each and every possible pair, and if by picking each and every pair, if suppose if and once we are picking each and every pair, so if suppose you are pointing at a given particular pair, right? And if the sum of the elements of these pair is perfectly divisible by value k, then we will increment our count, right? So basically the idea is we will use two nested loops for counting all the possible pairs we can have, and while iterating through all the possible pairs, we will have a check that will ensure that whether the sum of the elements in this particular pair is divisible by k or not, right? So let us now look the iterative step, right? So we will look how this nested or the counting all pairs, and then how we'll do this using brute force, right? So brute force means that we are using all the possible pairs we can have, so that's why it is called brute force. And so let us now look how this brute force will work step by step, right? So the given array to us was 2 comma 2 comma 1 comma 7 comma 5 comma 3, right? Now after this, actually silver coder, yeah, this video was uploaded yesterday, but due to some network issue the video was disconnected, so we deleted that video again and now we are publishing it again, right? So we'll discuss it again. Yeah, so now this is the brute force approach, right? We are discussing the first approach, which is the brute force. Now to count or to check all the possible pairs, what we'll do is that we will use two nested loop. That means we will have two pointers, right? The first nested loop, we will use an I pointer, which will mark the beginning of our current pointer, right? And in the second nested loop, we'll take a j pointer. Let us suppose that a j pointer is pointing here, right? So now we will be traversing for each value of I, for each pointer I in the first loop. We will count all the possible remaining elements, right? Because if I'm talking about pair, then pair means a comma b, right? So in the first loop, we are fixing this element, right? And in the second nested loop, we are finding this remaining element, right? So we will, I hope you're getting that what I'm doing to like check all the pairs. So in this manner, uh, initially our pointer will be pointing at 0, the first loop pointer, and the second will be starting from I plus 1, that is 1, right? So this is the first step. So now all the pairs in the first step will be 2 comma 2, right? Because we are fixing our first pointer at 2, and then j will be incrementing to this. So the next pair will be 2 comma 1. The another next pair will be 2 comma 7, 2 comma 5, right? And the last pair will be 2 comma 3. So now these all pairs are the possible pairs that we can have, but we have to now check whether how many of these pairs will satisfy a given condition, the condition that the sum of the elements of this pair is divisible by k, perfectly divisible by k, right? So now once we have all these pairs, we will check whether their sum is divisible by k or not. So in this case k was 4. So now we will check 2 plus 2 is 4. It is perfectly divisible by 4. So we'll increment count by 1, right? The count of our answer will be incremented by 1. 2 plus now in the next pair, 2 plus 1 is equal to 3. It is not divisible by 4, right? So we will move on to the next pair. 2 plus 7, 9, not divisible by k. Similarly, 2 plus 5 is equal to 7, not divisible by k. 2 plus 3 is equal to 5, not divisible by 4, right? So the pairs we found and the first iteration of the nested loops was only 1. Right. Similarly, in the same fashion, we will in the next iteration of the nested loops, I will be incremented to 1 and j will be starting from I plus 1, that is 2. Right. So in the next iteration, let us quickly look at the next iteration. What all pairs will be having. So in the next iteration, we will having a pair 2, 1, 2, 7, 2, 5, and 2, 3. Right. So now we will check, as discussed before, whether the sum of these all pairs, like the elements of all these pairs, will be divisible by k or not. So 2 plus 1 is equal to 3, and it is not divisible by 4, so it will not be counted. 2 plus 7, 9, not divisible by 4. 2 plus 5, 7, not divisible by 4, it will not be counted. 2 plus 3, not divisible by 4, not be counted. Right. So in the second iteration, we don't have any such pair such that the sum of elements of any of the above mentioned pair is divisible by k. So right, so we'll not be incrementing the count. Similarly, we will like iterate all the possible pairs. Right. So finally, after using the nested loops, when the nested loop will be over, so we will get a final answer. Right. So let us now discuss the time complexity. The time complexity of nested loop or the brute force approach will be big O of n square, where n is the size of this array which we are given, right? So n square, because as we can see that we are fixing each element and then we are traversing the remaining half of the array, right? So the first loop can be going to the last element, that is n, and similarly the nested loop can in the worst case can traverse n elements, right? So time complexity becomes big O of n square. Now let us discuss about the space complexity. So talking about the space complexity, we can see that we are not using any auxiliary space, right? So the time complexity pretty much easily becomes big O of n1. Right. So I hope this brute force approach is clear to you. But as we can see, the time complexity of this brute force is big O of n square and space complexity is big O of 1, right? So, but the expected time complexity was big O of n. Expected time complexity was big O of n, and expected space complexity was big O of k. So there are with this brute force approach, there is no issue with the space, right? Because we are using much lesser space than allotted to us, that is O of 1. But the issue is time complexity, right? We are using O of n square time complexity and expected is big O of n. So let us now look why big O of n square will not work, right? So the maximum size of this array which were given to us was 10 raised to the power 6, and as we discussed earlier in the previous videos that the total number of computations we can do in 1 second is 10 raised to the power 8, right? Around 10 raised to the power 8. But the time complexity is big O of n square in this case, so 10 raised to the power 6 raised to the power 2 becomes 10 raised to the power 12. Right? So it is this 10 raised to the power 12 is way much lot bigger than the allotted number of computations, right? So this will obviously give us a time limit exceeding, right? TLE. So this is why we will be now looking at the best and the efficient approach whose time complexity will be big O of n. So before starting the next efficient approach, I want you to focus on some of the concepts which we will be using in this next approach, right? So in this next approach, we'll be using the concept of remainders, hashing, right? So these two concepts will be used in the next approach. So let us now talk about the remainders, like how we calculate the remainders, right? So in C++, so in the coding world, what we do is that to find remainders, we actually use the mod operation, right? Suppose if I want to calculate, if I divide 9 with 4, right? So the quotient will be 2. And now if I want to calculate the remainder, that is how much extra, right? How much extra is remaining if I divide 9 with 4. So the manually calculating the answer is 1. So how do we calculate in the coding world is that we use the mod operation. So it will give us 1, the remainder, right? So it is quotient and this part is remainder. I hope most of you guys know about this remainder and how we can compute it, right? So I'm discussing for the for the people who are new to this coding world and don't know about the remainders and the mod operations, right? So now we will discuss the concept of remainders here, right? So what if I say that if I divide, let us look at the observation, right? So if I am dividing any number n by value k, right? So I ask you that what is the range in which our remainder will lie? That is, if I say that the remainder of this n by k is some value r, so what will be the range of this remainder? In which range the remainder will lie, right? So let us take an example to understand this more clearly. If I divide, let us take the value of to be 4 and n, okay, right? So now let us look the range of the remainder, right? So if I divide 1 by 4, right? So the remainder will be 1, 2 by 4, remainder will be 2, 3 by 4, remainder will be 3, 4 by 4, the remainder will be 0. Now this cycle will be continued again and again, because now after this, if I do 5 mod 4, the remainder comes 1, 6 mod 4, the remainder comes 2, and so on. So as we can see that this is forming a cycle, right? So these range of values will be repeated, right, time and again. So the range of the remainder, if we divide any number n by k, the range of the remainder lies between 0 to k minus 1, right? So this is the range of the remainder. So where we'll be using this concept of remainders is that we will create an frequency or the hash count array of our remainders, right? So suppose if I'm creating a hash count array for calculating the frequency of all the numbers having remainders, right? So in this case, k was 4. So the possible number of remainders will be 0, 1, 2, and 3. Let me delete this extra space I allocated by mistake. Okay. So now this is our, let us name as hash remainder. It will count the frequency of the numbers having remainder from range, like having remainders in the range 0 to k minus 1. In this case, k was 4. So let us now do iterations and understand how we will fill this hash count array, right? So now we will be understanding the concept of hashing. So the array initially given to us was 221753, right? So the array given to us was 221753 and 3, right? So now we will populate or fill this our hash remainder array, which will be storing the frequency of all the numbers having remainder from 0 to 3, right? So let me create this hash count array, right? So let us now begin filling this or populating this hash count array, right? So name it hash remainder. So now once we are iterating this our original array of integers, so what we'll do is that 2 mod 4, right? So remainder 2 will increment initially this hash count array will be initialized to 0. So all these values will be initialized to 0 in the beginning, because the logic of filling or initializing all these values of remainder with 0, because initially we are not having any number in our bank, right? So the count of numbers in each of these cell will be 0, right? I hope it makes sense. Now we will start populating this hash count array. 2 mod 4 will give us, okay, let me write it for you. 2 mod 4 will give us remainder 2, right? So we will increment the count here by 1. Similarly, in the next iteration, our pointer will be pointing at this element. 2 mod 4 again is 2, so we will increment the counter by 2 here. So in this manner, we will populate this array. So 1 mod 4 will be 1, remainder will be 1. So we'll increment the count of 1 remainder here 1. 7 mod 4 will give us remainder 3. So we'll increment the count 3. 5 mod 4 will again give us 1. So we will increment the count by 1 and this will become 2. Similarly, 3, the count will become 2. So this is our final hash count array of the numbers which are, so what we basically are doing with this hash count array is that we are counting the, or we are storing the frequency of all those numbers having respective remainders in the range 0 to 3, right? So we can see that there we have two numbers having remainder 2. So the in this cell of remainder 2 column will have 2 count, right? We have two numbers having remainder 1 when we divide it by 4, that is 1 and 5, right? So therefore we are having 2 here in this frequency count. Similarly for 3, we have two numbers, remainder 3, we have two numbers having remainder 3 when divided by 4, that is 7 and 3, right? So the count is here. So now let us, after populating this hash count array, what is the use of this hash count array? Why we have created, right? So this idea might be tickling in your head. So let us now discuss another concept, right? Now, if I say you that we have two numbers n1 and n2, right? And if we divide these both numbers by same value k, right? And let us suppose that remainder comes out to be r1 in this case and remainder comes out to be r2 in this case, right? So the remainder in case of this one is r1 and the remainder in this case of is r2. Now, what does remainder means? That is, there is some extra value due to which our number n1 is not divisible by k, right? So that extra number is r1, and similarly for n2 that extra number is r2. So now I'll prove you mathematically that if we do r1 plus r2 is equal to k, then the sum of these remainder of these two numbers will be always be divisible by k, right? That means that if we are having a remainder r1 and we have to find another number, this remainder was okay. So for once, forget this idea, right? I'll prove this equation to you from below approach. Okay. So if I say that we have a number n1 and by taking mod with k, the remainder is r1, right? And now we have to find another number n2 such that its remainder comes out to be, we have to find another number n2 such that if we do mod by k and it remainders comes out to be r2, then r1 plus r2 should be equal to k, right? So what we'll do is that we have the value k in our hand already known to us, then we will subtract that extra remainder, right? So through this we can calculate another value, right? So, or in other words, we can say that we have a remainder r1 and we have to find another number such that its remainder comes out to be r2, and the basic idea we want to implement is that we want r1 plus r2 equal to k. So if we have r1 from this, we can calculate r2 pretty much easily, right? K minus r1. So now let us prove why we are calculating this. Okay, suppose we are having two numbers. Let us take these two numbers to be 7 and another number let it be, okay, so let us discuss, right? So if I do mod with k, k in this case is here is 4, 7 mod 4 comes out to be 3, right? So this extra value is 3. Now to make, so we want to calculate a pair, right? So we have found this number and this number is having remainder r1. We have to find another number such that if we add this number to this number, the remainder becomes 0, right? So we know that remainder means that this is extra value, and to make this extra value perfectly divisible by k, we have to find another number n2 such that it remainders when added to this r1 makes the sum of r1 and r2 divisible by k, right? So we have to find this another number. So our equation reduces to 3 plus this number we have to find such that their sum when divided by k gives us remainder 0, right? So this is pretty much logical and observational that we have an extra number 3, and we want to make that number divisible by perfectly by k. So we have to add some value, right? Because we have to basically what we have to do is we have to find two pairs, right? And there's sum. So this extra 3 should have another helper that makes their sum divisible by k perfectly, right? So we have to find another number. So how we can find that is that we won't be finding another number, but we'll be finding as another remainder, right? So 3 plus, right? So let us take, okay. So now if another number n2 is 5, right? So if we take mod by 4, then this remainder comes out to be 1, right? So now if we do remainder of this number will be 1, so it is perfectly divisible by 4, right? Now to cross check, 7 plus we took n1 as 7 and n2 comes out to be 5, right? So the sum is 12, and this 12 is perfectly divisible by k, it is 4, right? So this is how we can prove that if we are having two numbers n1 and n2, and their sum comes, and if we take the mod by their sum, I mean if we divide the sum by a value k, then there comes out to be some remainder, and if we want that the sum to be perfectly divisible, then their remainders should also be perfectly divisible. The sum of their remainders should also be perfectly divisible by k. So this is the basic idea and basic approach, right, of this remainder. So now once we are done with this concept, let us now redraw this hash remaining array again, right? So it is 0, 1, 2 and 3. So our count was 2, 2, 2, right? So initially the count of 0 was 3. Now let us do like find how we'll be finding the total number of pairs, right? First of all, we'll iterate this hash array of remainders, and up to what value or to what index we'll be iterating this. So the main crux lies because we have to find like up to what iterator we have to iterate, right? So we will iterate till k by 2. K by 2 because as we can see that, okay, so I will come to this point later. So let me discuss like how I'll be calculating, right? So now as I told you earlier that if I have to find another remainder r2, so I have to do k minus r1, right? So this equation will be reduced to r1 plus r2 is equal to k, right? So this is our remainder array. Now how many elements we are having such that the remainder is 2, such that the remainder is 1, right? We are using indexes as remainders. I hope you observed this earlier, pretty much earlier, right? We are using indexes as remainders, right? So how many elements we are having in our original array such that their remainder when divided by 4 comes out to be 2, comes out to be 1. So there we are having total 2 elements. Similarly for this also, right? So now once we are pointing here, suppose we are pointing here, right? Our eye pointer is pointing here. So now we have to find R2 such that R2 comes out to be 3, right? Because we have k is equal to 4 and k minus 1, k minus r1 was 1, so it should come 3, right? So we have to find total number of elements having remainder when divided by 4 is 3. So now we have I as r1, right? So let us now r1 as I, and r2 will come out to be k minus I, right? So now once we know the r1, we know r2, then we will multiply the counts of each of these remainder values, frequencies, right? This is because as we all studied earlier that this is all about combinations, right? Suppose we have two elements here, consider 2 comma 2, and we have another element say 6 comma 6, right? So these are remainders. Okay, okay. These are, okay, let me erase it and explain it to you again. Suppose we have we have two sets of integers, right? In this set we are having 2 comma 2, in this set we are having 3 comma 3. So we have to find the total possible combination. So the total number of possible combination pairs will be 2 comma 3, right? This pair 2 comma 3 again, this pair and this pair, right? So the total number of pairs will be, how we'll find the total number of pairs, right? So we'll fix one element and pick all the other elements in the other set. Similarly for fixing second element and finding all other pairs, right? So the formula comes out to be the size of the first set element, right? So let us suppose the size of the first set would be n, and the size of second set would be m. So the total number of possible pairs come out to be n into m, right? So similarly, we'll do that here. So, right, so we have count of elements having remainder 1 as 2 and remainder 2 elements having count k minus I remainder, that is 3 as 2. So the total possible combinations or pairs such that their sum is perfectly divisible by k comes out to be 4, because count of elements having one remainder is 2. Similarly, count of elements having remainder 3 is 2. The total possible pairs will be 2 into 4, right? So now we will discuss that up to how much iterations we have to perform on this array, right? So now as we can see that if we cross the half limit value of this array, right, and the array means the frequency array of the remainders. So now we calculated this for first remainder. Now if we cross the half limit is 2 here, right? So the half limit here is 2, and now if our iterator comes by iterating all these values, our iterator comes out at this value, right? So in this case, suppose if our I is 3, right? So our I3 means remainder 1 is 3. So the remainder 2 comes out to be 1. Now now if I go to this 3 again, so we can sense that there will be duplicacy, right? We will counting the total number of pairs twice, right? Because it doesn't matter if R1 is, whether R1 is 1 or R2 is 3 or R2 is 1 or and R1 is 3, right? So the total number of pairs the count will always be remaining same, and the if we calculate them twice, so our answer will be wrong because we are adding the pairs twice, same pairs twice, right? So we don't have to do this. Now we have cleared some concept that how we'll calculate the possible pairs and up till what index we'll be iterating our frequency count array. Now after that, there will be three cases, right, while calculating the remainders or the total number of count of pairs, right? So the first case will be that suppose if we are having two numbers n1 and n2, right, we have to make pairs, and each of these numbers individually are perfectly divisible by k, that is their mod with k gives us 0 and mod of this number with k also gives us 0, right? So let us take example, right? Suppose we are having two remainders like this and this, okay, and another set having two elements such that remainder also is 2. So in this set we have two elements 2 comma 2 having remainder 2. Similarly, okay, let us erase this case. We have to talk about the case in which the remainder comes out to be 0, right? So let us take two elements, the first set 4 comma 4, and remainder of each of these elements individually when divided by 4 comes out to be 0. We're taking k equal to 4. Similarly here, if I take 8 comma 8, right, so the remainder also comes out here to be 0, right? Now we have to find the total number of pairs, right? So in this case the remainder of both these elements are 0, right? So if I say in place of this we can write all these, right? This will be remainder set. If I combine both of them, this will be a remainder set. So now if I want to count the total pairs, okay, so what will be the idea that this will be the first pair, this will be the second pair, this will be the third pair, right? Again this pair and this pair, right? Similarly, the last set of pair, right? So as we can see that the size of a remainder array, the size of a remainder array having remainder 0, a size, or we can say the total count of the elements having remainder 0 is 4, right? And now we have to find the total number of possible combinations within these elements, right? Because basically these elements are different, right? But the remainder is same, right? So we have to find the pairs. So the pair coming out would be 4 comma 4, right? 4 comma 8, 4 comma 8, 4 comma 4, 4 comma 8, 4 comma 8, and similarly for this element 4 comma 8, 4 comma 8, right? Right. So total possible pairs here are 1, 2, 3, 4, 5. Okay. I guess one more pair will be there, 4 comma 4, 4 comma 8, 4 comma 8. Okay, cool. So now here we are having 4, right? Size of the element is 4. So we can see as we were having 4 elements. So this is first, second, and third. So 3 pairs with this element 6. Now this one and 2, right? 2, and this one is last element, last pair, that is 1. So the total sum of all these pairs having remainder 0 are 6, right? This is the total count. So how this, so instead of like doing this manner, we know that there is a formula, right? A series formula for calculating the sum for consecutive numbers, right? So if we are suppose having n consecutive numbers starting from 1, n numbers starting from 1 and ending at some value, suppose n. So the sum comes out to be n into n plus 1 by 2, right? So we know this formula, but in this case we are having total size of the elements or the count of the elements 4, but the pairs, the series which is formed when we take the pairs is 3 plus 2 plus 1, right? So what we can do is that we can reduce this formula, and now we will put the value of n, change the value of n, because if we observe this series the value of n becomes 3, right? So we will put the value, so n was 4, but now while counting the pairs n becomes 3, right? So that is n minus 1. So we'll put this new value of n here. So n changes to n minus 1, here n changes to n minus 1 plus 1 by 2, right? So after solving it, the new formula from this which is reduced is n minus 1, this one get cancelled, n, right? So the new formula for calculating is n into n minus 1 by 2. This formula is for the first case, right? Now the second case will be when we are having two elements, and when we divide these elements individually with k, they are not perfectly divisible. Suppose the remainder comes r1, their remainder comes r2. So this is a general case, right? So the formula, or the formula by which we can get the total count of pairs will be hash count of r1 into hash count of r2, right? So it is pretty much obvious and logical, right? As we discussed earlier, this is a general case. Now the third case is that when the value of k, right? The value of k in this case is 4, is even. So how does this value, whether it is even or odd, affecting our answer? Let us now discuss that, right? Suppose if I say, let us take this case only, 4 by 2, right? It comes out to be 2. Now if we were iterating this hash count array, right? What we were doing is that we were finding r1, and with the help of r1 we were finding r2 by doing k minus r1, right? and now we have to, like, while counting the pairs, we have to count the distinct pairs. Okay, so that means we don't have to take the same, like if we are, suppose we are having element 2, 3 and 5, and we have to find all the pairs. So we will take different pairs with different indices, right? Elements with different indices in a single pair. So in, suppose this is the array, so we won't count the pair 2 comma 2, right? Because both of them has pointed to the same pointer. So this similar case will arrive here, right? Suppose my value of k is 4, and now if I'm pointing here, right? So my remainder 1 becomes 2, and my remainder 2 will become k minus 2, that is 2, right? So now we can sense that with this issue we can, there will occur a problem of duplicacy, right? Because we will, there might be a case that we can consider this element twice. This is the case which will prove this thing, right? So let us suppose that the count here was 2, right? And so there the frequency will also become 2, right? So now if I'm pointing here, so my R1 will be 2 and R2 will become 2, right? So the formula, if we do, becomes R1 into R2, that is 4. But actually, when we see this array, there will be only one pair, right? Because 2 comma 2. This will be the only pair, right, in this array. But if we use this formula, if we go by this concept, that we'll find R1, and with the help of R1 we'll find R2, the count of remainders, and we multiply them. So this will give us wrong. The actual answer is 1 and we are getting 4. This is wrong, right? Similarly, the above formula we use of n into n minus 1 by 2 will be used here again. Now I'll prove that how we can use this formula here again. Right. So the issue was when we are having k, the value of k is equal to 4. Right. So now let us take an example where we will face this issue. Okay. So the above array was, okay, so we will take different element this time having remainder 2. Okay, so 2 is another element, 6 is another element, 10 is another element, right? And let us repeat another element 2. Okay, so in this case we are having 4 elements, and the remainder of all these elements is, when divided by 4, is 2. Okay, so now if I do the count, right, total number possible of pairs, that will come out to be 2 comma 2, 2 comma 6, 2 comma 10, 2 comma 6, 2 comma 10. Right? These are different pairs because the 2 here are different, and we will have another last pair 6 comma 10. Right? So now, okay. So this was the case when we are having remainders with 2 values. So now, if R1 was 2, then R2 would also be have come to 2. So the answer that would have come should be, we are having 4, a count of elements having a meta 4, so it should come 4 into 4, 16. But in total we are having how much pair? 1, 2, 3, 4, 5 and 6, right? So the actual answer is 6, but if we use the concept of R1 into R2, that comes out to be 16, which is wrong. This is right. So how will we reduce that? So basically, what if I say that these are the actually elements and all of them have the same remainder, right? So I can write, if I consider the remainder set of these elements, if I consider the remainder set, right, convert this set into remainder set. So what will the set become? Right, because this will be the new set of remainders, because the element here are 2. 2 by 4 gives us remainder 2. 2 by 4 gives us remainder 2. 6 by 4 gives us remainder 2. 10 by 4 gives us remainder 2. So the same issue which was there in case 1 occurs here, right? We can observe that. So again we will see that 3 pairs, 2 pairs, and in the last one pair, right? So the again formula will reduce to n into n minus 1 by 2. Right? So these are all the cases we will be considering while writing the code. Now let us discuss the time complexity. I hope this approach is clear to you because we discussed step by step. Like we started with the modular operation, right? The mod operation, and then we discussed the equation we'll be using to find the counts, and then we discussed the 3 cases which we'll be encountering while writing the code. The 3 cases, in each of the 3 cases we will be using different mathematical formula to reduce the total count of pairs, right? So now let us discuss about the time complexity. As we can observe that we are only traversing the initial array only once, right? So time complexity becomes n, where n is the size of the array. And now if I talk about the space complexity, so we are using an extra array of hash count, right? Hash count array of remainders. So the maximum size, as I discussed, can be k minus 1, right? K, okay? Because the remainder will lie in the range k to k minus 1. So total size will be k. And in the constraint given above, the total size of the integer k can be 100. So space complexity will be big O of k, right? So we have met the required conditions of the question. That the question was asking us time complexity of big O of n and big O of k, right? So let us now dive in the coding part. Okay. So first of all, we will write the brute force approach, and we'll see that whether the brute force approach will work or not. Because as we discussed, the brute force approach will not work because of the TLE. It will give TLE. So let us now cross check whether actually it will, in actual, will it give TLE or not, right? So we will have a variable which will count our total number of pairs, and let us name it as answer, right? Now, after this, we will use two nested loop as discussed. In the first nested loop, we are fixing an element, and then we are, for that element, we are finding, suppose, let us take this, right, by an analogy. Suppose we are taking a set or a pair. The pair consists of two elements. Let us name them A and B, right? So now if I fix an element A, then we have to find another element B, right? So similarly, with the help of nested loops, we are doing the same thing, right? In the first nested loop, we are fixing the element of the pair A, right? The first element A, we are fixing with this loop, and in the second loop, we are finding actually the remaining element of the pair, that is B element, right? So I hope this analogy will be more easier to understand, and more easy to understand that why we are using nested loop, right? So we are having two elements, right? Element is array of I and another element is array of j using the two nested loop, right? So now we have to check whether the sum of both these values, both these elements, is perfectly divisible by k or not. That is their mod is 0 or not, right? This what was asked in the question. So if it is the sum of elements, both the elements array of I and array of j is perfectly divisible by k, then increment the count, obviously. Else we will not increment the count, and once this nested loop will be over, after the completion of this nested loop, we will be ensured that we have checked each and every pair in the brute force manner, and we haven't skipped any single pair, right? So the brute force, what brute force does is that it will check all the possible cases, right? All the possible cases here means all the possible pairs. So we will be guaranteed and ensured that we will not be missing any single case in the manner of in the case when we will be implementing the brute force, right? So when this nested loop will be ended, we'll have our final answer. We will return our answer, right? Let us now submit this, right? This will give us TLE. Okay. Okay. As discussed, we are giving TLE because it is a big O of n square approach, and in the worst case, the size of the array can be 10 raised to the power 6, and if we do square of this value 10 raised to the power 6, in the worst case it becomes 10 raised to the power 12, and obviously it will give TLE because the maximum allowed computations is 10 raised to the power 8 in 1 second, and it is 10 raised to the power 12, which is much way bigger than 10 raised to the power 8. So now, after getting the D method of this brute force approach, we will write our efficient approach, right, of using hashing and remainder. So this will be remain as it is because this will keep the count of our total number of pairs. So as discussed, we will keep the hash remaining array of size k, and we will initialize it with 0. Now we will populate this hash array. So we will iterate the original array, and after that we will populate this, and to do this we'll write this piece of code, right? So what this piece of code does is that, as we discussed earlier, that we are using remainder as index in this hash remainder array, right? So we have to actually count the frequency of the remainders, right? So array of I mod k gives us a remainder value, and we are using this remainder as index for this hash array. So we will increment the count at that particular index in the hash remaining array, right? So this is how we do hashing, and with the amount of more coding questions you will do in array, so you will be eventually gradually learning the concept of hashing. So this is one use of hashing in this question. Now we will initialize as discussed the first case, right? So let me write case number 1. And all the when we have the elements which are divisible by k, right? That means that is no remainder. Okay, so we discuss the first case in which we'll be having elements and which when divided by k we will leave no remainder, that is the remainder will be 0 when we do mod with k, right? So for this case, as we discussed the formula earlier, so the formula was n into n minus 1 by 2. Actually n here is hash count, hash remainder of 0, right? 0 because if an element is divisible by k, then therefore its remainder comes out to be 0, and the hash count of all such element will be stored in hash remainder of 0. So therefore hash into hash remainder 0 n into n minus 1 by 2, right? So yeah, this is our first case. So let me, this will be n, okay, and this will be n minus 1. So the formula, you can like relate the formula n into n minus 1, where n in this case is hash remainder 0, count of all the elements having remainder 0, and n minus 1 similarly, right? So now we will talk about the second case, right? Case 2, when we will have all the elements, we will have all instead of all, when we will have the elements which are not perfectly divisible by k. So now we'll be taking the case where we will be having pairs in which the elements are not perfectly divisible by k individually, right? So we will start a loop from 1 because we have took the case where we will be having elements with remainder 0. Now as we discussed that till what index this loop will be iterated, so discuss it will be k by 2, and we discuss the logic behind that, and also discuss that both I and R1 and R2 should not be equal because this will lead to duplicacy. So R1 in this case will be I1. So let me just comment it down so that you can relate it easily. and this is R2. Right? So we discussed it earlier that we don't want to repeat the pairs, so therefore R1 and R2 should not be equal. Right? So now we will increment the count of our answer by hash remainder of I is R1, count of elements having remainder as R1, and hash remainder of R2. So here R1 is I and R2 is minus I, right? So we will add all these possible combinations of pairs in our final answer that will be outputting or returning, right? So now this was case 2 and now we will discuss the case 3. Case 3 when the value of A will be even, right? So we discussed the issue that when the value of K will be even, we have to devise a new formula, right? So the formula was hash remainder of K by 2, right, into hash remainder K by 2 minus 1 divided by 2, right? This is the formula, okay? So now we have considered all these cases, all these three cases, and then finally we will return our answer, okay? So let us now take a overview of this code. First of all, we declared the answer variable which will be storing a count of total pairs that we have to return finally. Now in this step we created a auxiliary array or an hash array that will store the count of the elements having remainder in the range 0 to k minus 1. Okay. Now we are populating or we are filling this hash array. We are using this formula for or the this code piece of code or logic for incrementing the count or counting the frequency of the elements having remainder I. Okay. Now in the case 1, as we discussed earlier, we are taking all the elements which are divisible by k, that is no remainder is left. So in case of no remainder, the R1 is 0 and R2 will also be 0. So this was the case and the formula we devised. We discussed it earlier. And this is the general case when elements and both the elements N2 are not perfectly divisible by k. So we will be using we will normally be multiplying the hash count of R1 and R2. Right here in this case R1 is I and R2 is k minus I. Similarly, the third case is when value of k will be even. So we discussed it, what will be the issue. So we derived the new formula. Right? Now we will submit this code and check whether this is working or not. So now there is some issue. Okay, we have missed the semicolon here. Okay, work. So okay, there is some issue in our code. So let us see what is this issue. Okay, another array. We have taken the mod here. Okay. There is no issue in that. We have implemented array of I mod k perfectly, no issues. -2, whether we have done it perfectly or not, let us take a look. Hash remainder 0 into hash remainder 0 minus 1 by 2, this is also correct, and this condition is also correct, right? So final case when okay, so the issue is that we haven't checked whether k is perfectly divisible by not. So this is sometimes the mistakes we do in a hurry, that we just implement the main logic, or in this case we have implemented the main formula for counting the pairs, but we haven't write down the condition, because as we wrote down here that when the value of k will be even, then only we will be doing this computation, right? So this condition will make ensure that now it will run. So yeah, as you can see that after clearing all the issues or the bugs in that code, after reviewing it, we got the submitted or accepted answer, because the time complexity of this code was big O of n and big O of k space. So we could have done it much more easier and in the expected time complexity. So I hope you guys enjoyed and completely understood the concepts that we use here, that is concept of hashing, concept of mod, remainder, and the mathematical equations and mathematics we used here. So I hope you enjoyed this video and you learned completely. So now if you have any queries regarding or any doubts, you can write in the chat box and I'll surely answer your queries. So as we can see that Silver Coder, you said that this video was uploaded yesterday. Yeah, this video was uploaded yesterday, because but due to some network issue, the video was not able to fully complete it, right? So we deleted that video and we are publishing or recording this video, like doing the live session of this video again. Okay. So in the previous video, earlier video yesterday, we were not able to complete the coding part because of the network issue. It was the live stream was disconnected. So we discussed it again, and yeah, this question is easy for someone who have done this sort of question, who understood the concept of hashing and all, right? But some, because the logic here we use of the hashing array and how we will compute, sometimes it might not get stuck in your head because in the interviews due to the pressure and all other reasons. But if you have done these types of question earlier, or you're expert at the coding levels, then this might sound pretty much easier to you. But for the new beginner who want to prepare for interviews and who haven't seen such type of question, it is a good question to be asked in the interview. So yeah, I hope no one is having any doubt. So yeah guys, stay tuned for more such interview questions, and in the upcoming videos too, or and in the upcoming live sessions also, we will discuss the question, we'll pick a question, discuss the question and take your doubts and all. And after that we will implement all the logics from and all the algorithm from brute force to the best efficient approach, so that you can get the idea that how to answer a question in an interview and how to approach a problem statement, right? So we are not in this live sessions, we are not directly jumping onto the final solution. We are starting on the brute force approach and going to the final efficient approach by building and enriching our problem solving skills, and like how we will think in the interview, right? So this will pretty much help you in the interviews. So guys, stay tuned and get updated with all these interview questions. So thank you guys. I hope you enjoyed this video, and stay tuned and happy coding. Bye.